Good evening, my YouTube viewers. In this video, what we're going to talk about is the chi-square test and how you use the chi-square test distribution for hypothesis testing. And the chi-square test is an asymmetrical distribution, and it's used to test for categorical data or variances. So what we're going to check on this particular video is we're going to do a practice question, and it's a political analyst might use a chi-square test to determine whether voter preferences in an election match expected proportions. So we're going to answer this question in Python. And so in order to answer the question, first thing that we have to do is we have to import 3 libraries to do it. So the first library that we're going to import is going to be NumPy as NP, which is the numeric library. And then we're going to import scipy.stats as stats. So stats is the statistical module within scipy, which is a scientific library. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And then so after we've imported the library, we define some of our variables. So our observed voter preferences for parties A, B, and C is a NumPy array being 250, 200, and 150. And then we have our expected proportions, which is also a NumPy array, which is 0.4, 0.4, and 0.2. So that's 40%, 40%, and 20%. You have the total observed, which is the sum of the observed. So that's going to be 600, I believe. And expected equals expected proportions times total observed. So 600 times 0.4 will be 250, and then 600, I think. 600 times 0.4 will be 250, and then 600 times 0.2 will be 120. So it won't be 250, it'll be 120, so 480, 240. So 240 plus 240 plus 120 will give you the expected proportions. And then so now we're going to do a chi-square goodness of fit test. So the chi-square stat, comma, p-value equals stats dot chi-square brackets f observed, comma, f expected. So you put in the observed preferences and the expected preferences. So now we print our results, print chi-square statistic and p-value. So a chi-square statistic is 14.8 and the p-value is 0.0007, which is less than 0.05. So you have to reject the null hypothesis. So the observed proportions do not match the expected proportions. So here we go. We ask the question, if p-value is less than 0.05, reject the null hypothesis. Observed proportions do not match the expected proportions. So now what we're going to do is we're going to visualize the data, and we're going to create a bar chart to visualize the data. So the categories are Party A, Party B, and Party C, and X is a NumPy array with the length of the categories, which is 3. So we're going to plot the data onto a graph. So plt.figure brackets peak size equals 6, 4. And then we're going to plot the observed and expected frequencies. PLT.bar brackets x minus 0.2, observed, width equals 0.4, label equals observed, color equals blue, alpha equals 0.7. And PLT.bar brackets x plus 0.2, expected, width equals 0.4, label equals expected, color equals orange, alpha equals 0.7. So now we're going to add labels, title, and a legend. So plt.xtext brackets x, categories. The title is observed versus expected voter preferences. The X label is political party. The Y label is number of votes. And the legend, and you get a grid. So grid equals Y, axis equals Y, line style equals dash, alpha equals 0.7. And then you show it. So you can see the observed. The observed is in the blue and the expected is in the orange. So you can see that party A and party B, the expected is both 240, and party C, the expected is 120, and the observed party A is 250, party B is 200, and party C is 150. So it just says that since the p-value is less than 0.05, the null hypothesis is rejected, and the observed frequencies, there is a significant difference between the observed frequencies and the expected frequencies. So that concludes this video. The next video we're going to be talking about the F distribution. So I hope you decide to watch it.